Welcome to Rhino, a channel dedicated to project-based learning. I'm glad you're here. In this tutorial, we will learn how to create a simple REST API from scratch using Go and Docker. To follow along, you will need to have Docker installed and running. You can head over to their website to find the version that suits your environment. Even though we're using Go in this tutorial, you do not need to have it installed on your machine. Let's look at the most basic Dockerfile and docker-compose config file we'll need to get started. We've opened up the terminal in VS Code and changed into the directory where our projects are stored. Here we can create a new directory for our project and immediately change into it. We've called our new project Rhino Trivia because we're building a trivia API. Let's go ahead and create a Docker file that will contain the instructions we'll need to build our API container. And then let's also create a docker-compose.yml file so we can manage multiple containers within our project. With our project open in the editor, we should see our newly created files in the sidebar. Let's open up our Docker file and start adding instructions. We want to start building our own container from the official Golang image with the version 1.19.0. Specifying the version here will ensure your dev environment is the same as mine. Think of this step like we're installing Go on a fresh new machine. The only other thing we'll need to do in this step is to set our working directory. Docker containers run on Linux, so here we're using Linux file system conventions. That's all we need in our Docker file to get us started. Now let's work on our docker-compose.yml file. At the top of the file, we will set the compose file version to 3.8. We will have one service to begin with and we will call it web. The build property is the path to our Docker file. In this case, our Docker file is in the current directory, so we'll use a full stop here to indicate that. Next, we will map port 3000 from our container with port 3000 on our host machine. And then we'll set our volume to tell Docker where we want to persist the data from this web service. If we head into the terminal, we can run our container using the docker-compose up command. Because it's the first time we're running this container, it'll take some time to install everything. And then it exits because we aren't really doing anything other than an installation. Let's take a quick look at the logs. We can see here that the first step in the log corresponds to the first instruction in our Docker file, and the second step in the log matches the second instruction in the Docker file. When working with Docker, we need to run all our commands within the container's bash. To access this shell, we can use the command on the screen. If you notice, the command is referencing the web service that we set up in the docker-compose.yml file. Now that we're inside the container's bash, we can run the go version command to verify that we have in fact installed Go in the container. The Go version in our Docker file matches the Go version that was printed from the container. Now that we know how to enter our container, let's also learn how to get out of it. You may have guessed that we can use the exit command to do so. We've reached the first milestone in our project. You're doing a great job. In this section of the video, we will look at installing and managing dependencies in our Go container. We will need to be inside the container to run the installation commands. To enter the container's shell, we can execute the command on the screen. We will be using Go modules to handle our dependencies, so let's initialize that now. It is a good idea to name your package after the URL it can be downloaded from. This project will be available on my GitHub. So I'm going to use the repository URL as the name of my package. Please feel free to use your own URL for this step. We can tell the command ran successfully because we now have a go.mod file in our project folder. We'll be using the web framework called GoFiber to build out our Trivia REST API. We can install this within our container by executing the command on the screen. Now let's create a folder called CMD to hold our main package. And inside this folder, we can create our main.go file. Next, we can head over to the GoFiber documentation and copy the Hello World example they have provided. Then we can head back into VS Code and paste the example code into our main.go file. We've changed the string we're going to send, but the rest of the code is the same as the GoFiber example code. That snippet is enough to set up a Go Fiber app. We can now run our main.go file with the go run command and bind to our local host. We have to do this binding so our container and browser know how to talk to one another. The printout in the terminal indicates that our Go Fiber app is running. We can head into the browser to check it out. The string in the browser is coming from the snippet in our main.go file. At the moment, we have to enter the web service container every time we want to run our Go Fiber app. It would be nice if we could start up the app from the host machine instead. We can do this with a few changes to our Dockerfile and docker-compose.yml file. Let's stop our Go Fiber web server and head into our Dockerfile where we will add 2 new lines of instructions. The first line will copy all the files from our host into the container. The second instruction will run the go mod tidy command, which will ensure that all our required packages are properly installed. Then we can head into the docker-compose.yml file where we will add the command that launches our Go Fiber app. Adding this command to our docker-compose.yml file will allow us to start our Go Fiber web server by running the docker-compose up command from our host machine. We can exit our web service container and run the docker-compose up command in our host terminal. Everything seems to be working as expected because we can see the Go Fiber start message print out in the logs. If we head into the browser, our app should be running at localhost port 3000. Let's head back into VS Code and make some changes to our app. In our main.go file, let's add some text to our string. When we go back and refresh our browser, we do not see our changes being reflected. With Go, we need to rebuild our project to be able to see our changes. This can be a little cumbersome, so let's introduce a way to hot reload our app so that changes are reflected whenever we refresh our browser. Let's head back to our Dockerfile to add a new instruction that will install a package called air. Then we also need to create a configuration file for the air package. This will be a .file called air.toml. We don't need to populate the configuration from scratch. We can head to the air repository and copy the sample file from there. Then we can head back into our editor and paste it into our own file. The only thing we need to change is the build command. We need it to be pointing to our CMD folder where our main.go file lives. Now that our air package has been configured, let's use it. We can do this by heading into the docker-compose.yml file and updating our up command to use air instead of go run. Next, we should probably rebuild our container by running the docker-compose build command because we've made a few changes to the Dockerfile instructions. If we run the docker-compose up command now, we should see the air message and the Go Fiber message printed in the logs. Now we can make a change in our app and see it reflected when we refresh our browser. Let's make another change and test it in the browser again just for good measure. We've made it to our second milestone. Pat yourself on the back because you're doing awesome. In the next few sections of the video, we will work on adding a Postgres service into our Dockerized Go app. We can close most of the files to tidy things up. Oops, we need to edit our docker-compose.yml file, so we should probably open it back up. Then under our build key, let's add the env file key and have it point to the .env file. This file doesn't exist yet, so let's create it now. We will come back to our .env file later on to add some values. For now, we can move on and start creating a new container for our database. In our docker-compose.yml file, let's add a new service. We will be using the Postgres Alpine image that we can pull directly from Docker Hub. Because we won't be adding any extra instructions to our Postgres container, we do not need to create an accompanying Dockerfile for it, nor do we need a build property here. Next, we will map port 5432 from our container with port 5432 on our host machine. This is the port that is typically used by Postgres. And then we will set a volume to tell Docker where we want to persist the data from this service. We're going to use a named volume here so our Postgres data is always persisted and any removals would have to be done manually. Now we can head back into our .env file to add some environment variables that we will use to connect to our database. Here we have a database user, a database password, and a database name. Without any additional steps, we can already access these environment variables within our container. All we have to do is add them to the environment property. We will map the Postgres user to the DB user variable, the Postgres password to the DB password variable, and the Postgres DB to the DB name variable. These are the only environment variables we'll need for this tutorial. Now let's figure out how we can talk to our database. We could just write raw SQL because our app is small enough. But for the purposes of learning, let's see how we can use an ORM library called GORM. We will need to install a couple of new packages first. So let's enter our web service container by executing the command on the screen. Once we're inside the web service shell, we can install the GORM package. GORM supports several databases, so we will need to install the Postgres driver so we can get the functionality that is specific to our use case. One of the main benefits of using an ORM library is that it allows us to manipulate data from a database in an object-oriented way. With GORM, we can use Go structs to represent our objects. These objects can also be described as models, so let's create a new models directory and file to organize them. Within our models package, let's import the GORM package that we installed earlier. Then we will create a custom struct type called fact. We will specify that this fact is a GORM model. A fact will have a question field which will be of type string, and an answer field which will also be of type string. We will use JSON struct tags to describe the corresponding lowercase JSON keys for each of our struct fields. We will also add GORM struct tags to our fact fields. Both our fields will be represented as text columns in the database. Neither column will allow null values, and we will also set the default value for both columns to be null so that we can return an error if the user does not provide their own values when they create a fact. Now that we have our GORM model set up, let's work on connecting to our database. We can create a new database directory and file to organize the related code. Within our database package, let's import the GORM package. Then we will create a custom struct type called DB instance. This DB instance type will have a DB field, the type of which will be a pointer to gorm.db. We will also create a package level variable called DB with capitals. This variable will have the type of DB instance. Next, we will create a function called connectDB. Within the body of this function, we will start setting up the gorm.open method, which will open up a connection to our database. The gorm.open method takes two arguments. The first argument will be a GORM dialector. In our case, this will be related to Postgres. The second argument will be some options. So far, we've been using placeholders to represent the arguments. So let's start by replacing the first one. For our dialector, we will use the Postgres.open method, which takes a data source name string as its only argument. We should also remember to import the Postgres driver while we're here. The data source name string does not exist yet, so let's create it now. We will set the host to DB. The user will be interpolated from an environment variable that we will pass in. The password will be interpolated from another environment variable. The DB name will also be interpolated from yet another environment variable. The port will be set to 5432, which is the typical port for Postgres. We will disable SSL mode and set an arbitrary time zone. That is the structure of our DSN string. Now we can replace all the placeholder variables with their corresponding environment variables by using the os_getEnv function. We should also remember to import the fumpt and os packages since we are using them. Now it's time to pass in some proper options as our second argument to the gorm.open function. We will use a pointer to gorm.config and set the logger property to a default logger set to info mode. Now let's also check that our necessary packages have been imported. The gorm.open function returns a database and an error, so let's do some quick error handling before we move on. If we hit an error, we will log the error and exit the program with an error code of 2. If there are no errors, we'll just log messages to say we've connected. Next, we will use auto-migrate to create the tables that we need from our GORM models. We only have our facts model, so let's pass that to auto-migrate. Then we should also ensure we're importing our models package. At the end of our connectDB function, we want to set the value of our global DB variable to the database we just set up. And with that, our connectDB function is complete. We can head into our main.go file and make use of it. First, let's ensure we're importing our database package. Then at the very top of func.main, we can call our connectDB function from our database package. We've made it to our third milestone. We got a lot done and you're doing a wonderful job. In the last part of this tutorial, we will create some routes and some endpoints. In our main.go file, we will set up our routes after the line where we create our Go Fiber app. This setup routes function we have used does not exist yet, so we will have to create it. First, let's create a new file for our routes. This routes file is part of the main package, which is why it lives in the CMD folder. We will import the Go Fiber package, then we will create the setup routes function. This function takes a pointer to a Go Fiber app as its only argument. Now we can move our existing routes from the main.go file into this dedicated routes file. We can further clean this up by moving the handlers into a separate package. Let's create a new handlers directory and file to organize the related code. Within our handlers package, let's import the Go Fiber package. Then we can set up our home handler. All handlers take in the Go Fiber context as an argument and they return an error. We can copy over the contents for this handler from our routes package. Then we can use our new home handler in our home route. We will also remember to import our handlers into our routes package. We have enough here to start testing our home route and endpoint. We will exit our container and start up our Go Fiber web server by running the docker-compose up command. Then we can head into our API client and use the get method to test our home route and endpoint. We know this is working because we can see our div Rhino string come back in the response. Back in the editor, we can take a look at the logs for a second. We can see that some SQL was executed to create a facts table and a new index. These queries were run for us by the auto-migrate function. Now let's create a new route at /fact so we can have the ability to insert new facts into the database. We are using the createFact handler, but it doesn't exist yet, so we will have to create it. Back in our handlers package, we will put together the createFact handler so we can create some new facts. Go Fiber gives us a function called bodyParser. We can use this to parse a new fact. The bodyParser function returns an error, so let's do some quick error handling before we move on. If we hit an error, we will return the internal server error status code and a JSON formatted error message. We should also import our models package and then fix this typo too. If there are no errors, we can go ahead and persist this fact to our database. Let's also remember to import the database package as well. Then we will return a success status code and our new fact formatted as JSON. We can test this new endpoint in our API client. We will use the post method and the /fact route. Then we will add some JSON data into the body of our request. We are sending a question and an answer for our fact. Once we hit the send button, we will receive our response, which will be our newly created fact formatted as JSON. We're going to head back into our routes package and repurpose our home route so that we can use it to list all our facts. We will also have to go and update our home handler so it matches. This renamed list facts handler will go and find all our facts from the database. Then we will return a success status code and all our facts formatted as JSON. We can test these changes in our API client. We will use the get method and our index route. Once we hit the send button, we will receive all our facts in the response. Currently, we only have one fact in our list, so let's post another one. How many time zones does Brazil have? Brazil has 4 time zones. When we hit the send button, we can see our second fact has been created and returned in the JSON response. Now when we make a GET request for all our facts, we receive 2 facts in the response. Finally, let's create one last fact for good measure. How many time zones does Russia have? Russia has 11 time zones. When we hit the send button, we can see our third fact has been created and returned. Now when we make a GET request for all our facts, we receive 3 facts in the JSON response. And there you have it. In this tutorial, we learned how to build a REST API from scratch with Go and Docker. We used Postgres to persist our data and Docker-compose to manage our containers. A text version of this tutorial can be found on divrhino.com, and a repo can be found on my GitHub account. I'll leave both links in the description for this video. If you enjoyed building this project, please let me know in a comment, or like the video and subscribe to my channel. Thank you for watching. I appreciate you.